All right, so today we're going to continue our look at area, and we're going to be looking at area of what are called polygons. Poly just means many, and if it's a gon, then that means it has many sides, many angles. So squares, rectangles, triangles, many sides. Okay? All right? So, Gesundheit. So, what we're going to do is we're going to look at some formulas for these. Yes, you must memorize the formulas, but of course they're formulas that you've seen 1,000 times. You may use your calculator. That's not a problem. But the big focus is on some applications using these. So we'll look at some of those as well. So not only do you have to find the area, then they're going to ask you things about costs or other things. So you're going to have to know whether you need to multiply or divide. But they're quite easy for you guys, I'm sure. So let's just jump right into them. Okay. So, first what we're going to talk about is area of a rectangle, and you'll remember we saw something very similar to this. If it's all divided up into perfect squares, then you could find the area of this by simply counting the number of squares. But we also talked about this formula for area of a rectangle. It's length times width. You could also call width height if you prefer. Just depends on you, whichever you like, okay? We do have to always remember, though, the idea of units, because you're not only multiplying the numbers times each other, you're also multiplying the units times each other. So we will get units, what, for area? Squared for area. And you can either write it as units squared, or you could write it as square units using the word. It makes no difference to me, but mathematically, this one is probably the more correct one. And besides that, it's just faster and easier to write. And if you want to say units squared, you're perfectly safe saying u squared too, if you wanted to abbreviate it even further. Okay? Now, this can't be used always because u could be a variable, right? So a letter in an algebraic expression or equation. So be careful. Units squared would be preferable, but if you wrote u squared, I would not count it wrong. Okay? All right. So we're going to look at a few of these and mainly talk a little bit about the applications. So we've looked at some of these. We have 9 centimeters by 13 centimeters. You just multiply those together. And of course we get centimeters, what? Squared. That is the most common mistake, is forgetting to square the units. Okay? You can do the same with decimals. And again, you're not going to have to worry about the math because you're going to have your calculator to do that for you. Okay? So, finding areas of rectangles. What does it mean when you have these little lines? That they're the same? Yeah, the same as the one that's measured. Good. Okay. All right. So, here's what I'm talking about applications. Estimate the area of an A4 sheet of paper in square centimeters. So, this one they want an estimate. So, do they want you to measure it? No, they just want you to kind of think about it, see what it looks like to you. So make sure with an estimate, it's actually an estimate. And I cannot warn you enough. If it says estimate and you measure, even though your answer is more correct, it'll be counted wrong.
But what happens if you didn't measure?
And you got it perfectly? It could happen. Right? But if I were going to do that, I might say, since I know that an A4 sheet is blah, blah, blah. So do you see you're justifying the fact that you got the exact answer with an estimate because of prior knowledge? Then that makes sense. Okay? But the chances of you just guessing the size of an A4 sheet, pretty slim, right? Getting it perfectly. But if you know it and you have prior knowledge, as long as you acknowledge that you knew before you started, then if your estimate is perfect, then we can still consider it. Okay? But know the difference between an estimate and a measure. Do not measure when you're doing an estimate. Just give it your best shot, right? Now, if you estimate it and it's 3 millimeters by 5 millimeters, we can't give you credit for that, right? That's just goofy, right? Because you know a millimeter is tiny. So make your estimate realistic. But they'll give you things that are realistic, like the A4 sheet, something that you're very familiar with. We wouldn't give you the estimate the dimensions of a car or something that you're not familiar with, or that can be all kinds of dimensions, right? Because cars are all different sizes. So if we do ask you to estimate, then the estimate will be something that you're very familiar with. Okay? But do not measure those. It'll cause you trouble. Okay? All right. And then they simply ask you to measure the dimensions. And then use your measurements to calculate the area of the sheet. And then they want you to just look at how close your estimate is. So what you're doing here is you're just gonna be trying to see how you feel the measurements, right? Okay? Centimeter is about what? The fingernail width. So you could kind of get a good shot. Yeah? You could kind of estimate by just putting your finger there. It's not an estimate does not mean you can't use tools. It just means don't use a ruler. Okay? All right. Good.
So what,
all right.
You can go like this with your finger and just...
Yeah, because you're not going to get an exact measurement, but it'll give you a close enough, right? Okay. Look at example 9 here. A hallway is 8 meters long and 90 centimeters wide. Find the area of the hallway in meters squared. So, first of all, what right off the bat is wrong with this? They're different units, and we want them in meters squared. So what we want to do is turn our centimeters into meters, right? So meters, decimeters, centimeters. So that means we're going to jump 2 places to the left. So if it's 90, the decimal is at the end. So if we move it 2 places to the left, that makes it 0.9 times the 8, which would give us our measurement of 7.2 meters squared. And again, you don't have to do the multiplication in your head. You could do that with your calculator if you're nervous about that. Make sure you have square units when you do get those. Remember, this one, we're not moving square units yet. So it just jumps twice, so do just 2 jumps. If it was measuring in square units, I would take those 2 jumps and, double them. Yeah, times them by 2 to get 4 jumps. Yeah, remember that? All right. Now, here's the new part. If carpet costs $40 per square meters, how much would it cost to carpet the hallway? Well, it's $40 per square meter. So that means every square meter costs what? $40. So you simply take the number of square meters you have times $40 to get your cost. Now, notice that your cost is in dollars, not in meters. Okay? And I'm going to show you why, but you do not have to demonstrate this for me as you do this. So think about how much we have. We have 7.2 square meters and $40 per meter. Let me show you why the meters squared is going away. Do not panic. You do not have to show this, right? It's 7.2 meters squared at a particular cost, so times, and it's $40 per square meter. And remember, we visited that word per before. It always means divide. Do you remember that? Somewhere back in your murky past, you've seen the word per means divide. And so what's happening here is, before I multiply with fractions, I always simplify. And anything that's the same in the numerator and the denominator will divide away. You like to use cancel, and I hate that word. So that's what's happening is the meters squared just divide away. Because the meter squared is in the top of one fraction and the bottom of the second fraction. So they simply divide away, which gives you then 288, and dollars is the only unit left. Okay? Now again, you don't have to show this, but you need to understand that the meters squared are dividing away, because when you finish, do not write $288 meters squared, right? So be careful. So you may or may not have seen this before, but that's what's going on with it. Anytime you see that word per, $40 per meter squared is the same as $40, over meters squared. And that's what's happening to those units. Okay? So again, you don't have to demonstrate it now. Later on, in another course, as you move forward in your mathematics, yes, you will have to demonstrate what's going on. But for now, you don't. Okay? This is called dimensional analysis, if anybody's interested. No? Okay. Well, I like it. All right. So, now we just added that one more layer. So, cost per meter. So, how long will it take to mow the whole green if 30 square meters can be mowed each minute? 30 square meters per minute. Okay? So, all right, so 1 minute for 30 square meters. So you can put it that way and it'll make it go away. All right. Got it? So you're going to be working on some of those. Be careful. Sometimes it's multiplication. Sometimes it's divide. It depends on what it is you're changing. Right? So be careful. Just think about the fact that you need those meters squared to go away. Right? So that means meters squared needs to be in the top of one fraction, and that's always the area measurement. And it has to be where in the other one? In the bottom. Okay? So be careful. All right. So you'll be working with some of those. You're also going to be working with the next shape, which we have is a triangle. And again, we have a formula. For any triangle, it's always area equals 1/2 times base times height. You might have seen this as base times height divided by 2. Multiplied by 1/2 is the same as divide by 2. So sometimes it's better to use one or the other. If you can multiply base times height and get an even number, in other words, a number that divides by 2, then it's easier to multiply first than divide by 2. If one of these will divide by 2, it's easier to multiply it by 1/2 first. But it makes no difference. Okay? If you always want to use this, because you're going to use your calculator to do the math anyway, right? This formula is a lot faster. Base times height.
Is it
Now,
always right, though?
yep, always right. Now, here's your issue, though. You need to know where you're measuring the height. The height of a triangle, the base of the triangle is always the bottom, okay? And the height is always measured from the base to the highest point. Now, that's pretty easy on this one. It's really easy on this one because the height is actually one of the sides. But if you look at this triangle, the base is along the bottom, but the actual tallest point happens outside of the triangle. It doesn't matter. You just extend that baseline and then measure up. Okay? So be careful. It has to be from the base all the way to the top. And you can turn the triangle if you need to. Okay? But generally, they're going to tell you which piece is the base. So they'll tell you which line to use as the base. Because otherwise, if you change it, right, it doesn't make any difference. You still get the same area. But okay? So be careful, especially with this thing. You may be measuring the height on the outside. So if you always want to do is base times height divided by 2, that's perfectly fine. Be also aware of how they want the answer. They may want it as a decimal, or they may want it as a fraction. But remember, you have a key for that. What's the key for that? F arrows D, right? Remember that? We change a fraction to a decimal. We looked at those keystrokes now? Yes? Okay. Well, let's look at it really quickly then. So, look at your calculator, and you should see a key that has F, and then 2 arrows, and a D. Do you see it? It could have on your calculator S to a double arrow and a D.
Yeah, mine was S to D.
Okay, there you go. So that one, by pushing that key, what will happen is it'll change your fraction into a decimal or your decimal into a fraction. Okay? So if you get a decimal answer and they want a fraction, do you have to change it yourself? Nope. Just pop that key and it'll change it to a fraction. Okay? Pardon? How have you not known this? Because
We just press SD and then type it.
all right, so if you want to enter a fraction, you can do, so for example, you want to enter the fraction 1/8. You can do 1, then that fraction bar key that is 2 keys under the shift key from the very top, and then 8. You must hit equals, though. If you don't hit the equal, it won't tell the calculator that you're through putting in numbers. And then you can hit S D, and it'll turn it to a decimal.
What is the
Okay.
F and the D stand for?
The D is a decimal. Usually on simple calculators like this, it's FD, fraction to decimal. I don't know why they use S. Who knows? Standard form to decimal. I don't know. I'm making that up. Okay? All right. So you can use your calculator to do these, to do the work, to multiply with a fraction, the whole bit. Okay? All right. Next shape. Go. So you're going to have some exercises where you're doing some triangles, including some where they have. But never mind. Cause some things I thought they did, but they don't. The next shape we're going to look at is parallelogram. Well, parallelogram is just another way of saying rectangle, but it's crooked, right? So, but like a triangle, it's base times height, but you don't divide it by 2, because if you look at it. A parallelogram is 2 full triangles, isn't it? That are the same size. And that's why you don't divide it by 2. So because you have the whole shape. So it's just base times height. And the base is always the bottom. Again, because it's crooked like that, you have those angles, you might be measuring the height on the outside. Okay? Well, yeah, you could measure it on the inside too, because it doesn't matter, does it?
Can you just move it back to being a rectangle?
Well, not really, because when you push that over, that length is. You're usually not gonna know that length here. You're gonna usually know a base and a height. So just use that. Okay? All right. Do not worry about the fact that you can cut them and change them into rectangles, but you see what they're doing? They're just cutting this triangle off, sticking it over there, and that turns it into a rectangle. That's why the formula for parallelogram is identical to the formula for, right, a rectangle. Okay? Different question? Yes.
Can we do a Kahoot this time on like random shapes?
Come on, we might. Okay. And then finally, the last one, I think, is the trapezia. Now, remember that with a trapezia, you have a base, and then you have another side of it, and they're not the same length this time. So it may look something like a parallelogram, but you see that this instead of going out this time, what's happening is it's cutting into the shape. So you get one long side, one shorter side, and 2 angles. Okay? And those angles do not have to be the same angle. All right. Now, this formula is a little more complex because it's kind of like having the triangle formula and the parallelogram formula, but notice here it's not, you have 2 sides, 2 long sides. So we're going to have to add those together. And then we divide it by 2, and then we multiply it times our height. So that one's a little harder to memorize. Make sure you memorize them, though. So it's A plus B divided by 2, and you need to do that first, and then multiply whatever that you come out with times your height. Okay? Pardon me? So, say this was 4 and this was 2. I would take 2 plus 4 divided by 2, which is 6 divided by 2 gives me 3 times whatever let's just pretend that the height here was 1.5. So we just multiply that times 1.5 and get your answer. Okay? So, easy peasy. You just have to remember, you have to add these 2 together and then divide by 2 to get what you're doing is you're getting your base measurement. Okay? But it comes off of 2 measurements.
So it'd be 2 plus 4 divided by 2?
So then that would give you 3. And then times whatever your height is. And again, I just made those up. Okay? All right. Now. Okay. Let's see. So they give you a couple of those to do. And some values. So you can use those in. And that's it. So you're just going to be using some different shapes, finding the areas. Sometimes you might be looking for the cost, etc. Be careful with that. You know which thing to do, though. If you'll think about that dimensional analysis thing that I showed you, if you have meters squared in the top, times something. In order to make those meters squared, where does the other meters squared have to be? In order to make them disappear? In the bottom, which means whatever else you have is going to be in the top, your multiplier, right? Because you have to make those meters squared divide away, and the only way to do that is to make sure your meters squared are in the bottom, okay? So if I have some formula or whatever that they give me, I have to make sure that I put the meters squared in the bottom and the other thing in the top. Good?
Yeah.
All right. So you have some homework. We're going to do all of these 3 different things with the shapes. Yep. So sad. So 11D.
Do it with someone.
So you're going to do 11D.1 through .3.
Oh, yeah,
They won't take very long with your calculator. Okay? There you go. Enjoy.